फर्स्ट एग्जांपल से मल्टीपल पहले एग्जांपल से स्टार्ट करो, जितना करवाया है उसका प्रैक्टिस स्टार्ट करो, ठीक है।
Hello everyone, good afternoon. I'm audible. Good afternoon to all. Okay, so let's start the session. In last lecture, we had discussed method of Newton-Raphson and its procedure to derive its formula by using the Taylor series method. So this is a procedure to derivations of Newton-Raphson's formula by using the Taylor series method, and we have its formula, that is xn plus 1 is equal to xn minus f of xn upon f dash of xn. Okay, for n is equal to 0 we can find the first iterations, for n is equal to 2 we can find the second iterations, then after by using n equal to 2, 3, 4, 5 and so on we can find the required iteration. Okay, and after that in this formula of x1, the x0 minus f of x0 upon f dash of x0, the value x0 is required. So it is already given in this questions, and if it is given, use this value as a x0 and find the x1. And if it is not given, so how we can take this value of x0? You just predict one interval AB where f of a is a negative, f of b positive, and then after we can consider it average value as a plus b by 2 for the value of x0. If it is not given, we'll use this trick to predict the answer of x0, and then after we can easily identify the x1 and so on. And if it is already given, use this value in this formula and find the x1 first iterations for the roots. Okay, and now after that we had discussed the first example, x2 minus 5x plus 3 is equal to 0 in the last lecture, and here x0 is already given, and just write as the formula. The formula is here, xn plus 1 is equal to xn minus f of xn upon f dash of xn. The derivative is required. Okay, so first derive its derivative. Fx is given x2 minus 5x plus 3, so here it is a derivative 3x square minus 5, and here x0 is given. So write the formula of first iterations by using n is equal to 0. So formula will become x1 is equal to x0 minus f of x0 upon f dash of x0. Okay, and then use the value x0, find the function value as well as the derivative value, replace it here and simplify it. You will get first iterations of the equation x cube minus 5x plus 3, that is a 0.5, and by using the 0.5 we can find the second iteration, that is x2 is equal to x1 minus f of x1 upon f dash of x1. Okay, use the n is equal to 1 in this formula and use x1 is equal to 0.5 to there, and we can find the second iteration answer. Okay, so in this questions two iteration is required only. Okay, derive the answer up to the second iteration. So this is our final answer in this example. If it is given here 5 iteration up to the 5th iteration, then we'll predict x3, x4, x5 and so on. Okay, so this is the solution of this example by using a Newton-Raphson method. Okay, and now in this second example that we were discussing the last lecture, that data was there 3x is equal to cos x plus 1, and this is a function fx equal to 0 form, 3x minus cos x minus 1 equal to 0, that is fx equal to 0 form. Okay, and this is a derivative f dash x is equal to 3x plus sin x, and here x0 is not given. Okay, in this questions x0 is not mentioned, but here it is required to predict the x1. So let us first find the x0, that is the evaluations of x0. Take one interval AB where f of a is a negative and f of b is a positive. Okay, and then after consider the average value. So here f of a, that is a is equal to 0, f of b, that is b is equal to 1, and at a it is negative answer, at b it is positive answer. So a plus b by 2 will be the 0.5, so that will be our x0, and by using that we can predict our required answer. Okay, So here answer is required up to the 4 decimal place, correct, up to 4 decimal place. Iteration is not mentioned that you just derive of 5 iteration only, you just derive 3 iteration only, that is not given that, but condition is there. Check your answer, okay, correct up to 4 decimal place, okay. Means when we get 2 consecutive iterations correct up to 4 decimal place, then we'll stop this procedure and we'll consider that is our required answer, okay. So that is x0, that is a f of x1 output, that is f dash x output, okay. And then write formula of x1, that is x0 minus f of x0 upon f dash of x0, okay. All these three value you have, that is a point x0, function output, just replace 0.5 to the 3x minus cos x minus 1, you will get answer minus 0.377. and after derivative you have 3 plus sin x, 3 plus 0.5 to that, you will get answer 3.4794. Use this all three value in the formula, that is x0 minus f of x0 upon f dash of x0, correct. And now replace the value 0.5 minus 0.377, 3.4794 to that, simplified, the solutions will be 0.6083, okay. And consider the 4 value after the decimal because it is required in the answer, correct up to 4 decimal places, okay. So repeat this procedure for the second iterations. X1 will be 0.6083, use 0.6083 to the function and find it output, that will be 0.00427, and after 3.5714 that will be the derivative output, okay. And use this all three value in the formula of x2, x1 minus f of x1 upon f dash of x1, okay. And it will be 0.6071. Again repeat this procedure for third iterations. X2 is, we have 0.6071, that is it output for function value, that is a derivative value 3.5705, and use in the formula of x3, that will be x2 minus f of x2 upon f dash of x2, okay. That is x2 minus f of x2 upon f dash of x2, okay. Replace all these three value in this formula and simplify that, you will get answer 0.6071, okay. So now check the x2 and x3 answer. This answer are same, correct up to 4 decimal places, means after this decimal the 4 value are same here, okay. So at that stage we'll solve this procedure and we'll consider this x3 answer, that is the required answer, and that is the answer, that is the approximate root of the equation 3x minus cos x minus 1 is equal to 0, okay. So up to this we had discussed in the last lecture, and now today we'll discuss another two example related to this topic, and then after we'll start the next concept. So third example is there, find the root of the equation x into sin x plus cos x equal to 0 by using Newton-Raphson method, using which is near x is equal to pi, correct up to 4 significant digits, okay. That is the given condition here. We'll check our answer correct up to 4 decimal places, otherwise 4 significant digits. The meaning of this both words are same. So first step for this type of questions, consider the functions as the fx equal to 0 form. So this is the proper form is already given, x into sin x plus cos x equal to 0, okay. And now identify derivative, means let us derive derivative of the fx. So here the product of two function is given, x into sin x. So there we'll apply the product rule of derivative. And what is the product rule of derivative, that we are no, okay. That is f of x into g of x, that is a product of two function. So first function as it is, derivative of second function is there, okay. And then after second as it is, derivative of first one, okay. So f of x into g dash x plus gx as it is, derivative of f, that will be the f dash x. So here is given that x into sin x, so x as it is, and derivative of sin, that is a cos, and then after sin as it is, derivative of x, that will be the 1, okay. So it will be x into sin x, x as it is, derivative of cos, derivative of sin, that will be the cos x, and plus, then after sin x as it is, and derivative of x, that will be 1, okay. D by dx with respect to x, that is 1. And next term is there cos x. So what the derivative of cos x, that is a minus sin x, clear. So simplify this one, that is a x into cos x plus sin x into 1, that is a sin x only, and minus sin x. Okay, so here positive sin x and negative sin x, that will be removed. Okay, so just in this form, remaining term is only x into cos x. Okay, and this is the derivative of the given equation. So f dash x, that will be x into cos x. Okay, it is a sin x and minus sin x will be removed, and remaining only the first term is there. It is a x into cos x. Okay, and now here x0 is given, that here we'll check our iteration, we'll check the roots nearer to x is equal to pi, means x0 is equal to pi. Okay, so x0 is also mentioned in this example. So let's start with the x0 is equal to pi, and let us check the first iterations by using x0 is equal to pi. Okay, so here x0 is equal to pi is given. Okay, we'll check our root nearer to x is equal to pi, means a starting point is already given in this example. Okay, so we'll take x0 is equal to pi. This is our first approximate root, and now let us check the remaining iteration. Okay, so we'll prepare this type of table for Newton-Raphson method. First column, the number of iteration. Second is the values of xn. Third is a function output f of xn. Fourth is a derivative output f dash of xn, and last is our answer, that is formula xn plus 1 is equal to xn minus f of xn upon f dash of xn. Okay, first iteration, we have x0 is equal to pi. Okay, for n is equal to 0, we'll find the first iteration. So here we'll f of x0. So let us check the values of f of x0. So f of x0 is here x into sine pi, means x into sine x plus cos x, that is a given here. Okay, so replace x is equal to pi and check the output in radian mode. Otherwise you can directly predict that value, because we have the well-known values of sine pi and cos pi. Okay, so pi into sine pi plus cos pi, that is the formations that x is equal to pi. So sine pi, that will be 0. Okay, pi into 0, so it will be 0 here, plus cos pi. So cos pi answer is a minus 1. Okay, so remaining output, that is a minus 1. Okay, so f of x0, that will be the minus 1. Okay, and now f dash of pi. So f dash of x, we have x into cos x, so replace x is equal to pi there. So f dash of pi will be pi into cos pi. Okay, and what is answer of cos pi? That will be the minus 1. So f of cos pi, that is minus 1, pi as it is here in this product, so it will be the minus of pi. Okay, so that is answer minus pi. And then after xn plus 1 formula. Okay, so by using n is equal to 0, we'll predict x1. So x1 will be x0 minus f of x0 upon f dash of x0. Okay, and now replace x0 in this form. So x0 we have a pi. Okay, minus f of pi, that is a minus 1, and f dash of pi, that is a minus pi we have. Okay, so there is 3 negative sign here in this product, so remaining sign will be the negative. So it is a pi minus 1 upon pi. Okay, pi minus 1 upon pi. And now use the values of pi that is already fixed in your calculator. Okay, you can use it by using a shift exp tab. Okay, there is one tab near to answer in this last row. You can use it by using shift exp. Just press shift exp tab, and you can use the pi output. Not consider only 3.14, but you just consider this pi values directly from your calc. So just take pi minus 1 upon pi. Yes, am I audible? Everyone? Okay, good. So check the values of pi minus 1 upon pi. Yes, what will be the answer? That you will get 2.82328 something. Is it correct? Pi minus 1 upon pi. Use pi notations from your calculator. Okay, not consider only 3.14 as a value of pi. Just use the pi notation that is already given in the calc. Just you can use it by using a shift exp tab. okay, from your scientific calculator. So pi minus 1 divided by pi. So it will be a 2.82328 something. Okay, this answer you will get pi minus 1 upon pi answer, that will be 2.82328277. Okay, this answer you will get in calculator. So let us consider up to the 4 otherwise 5 significant digit 82328. Okay, this is the answer of x0, and now use this answer in the next iterations for n is equal to 1. So this value will become x1. Okay, 2.82328, and now check the function output 8 at the value 2.82328, and we have function is there x into sin x plus cos x. Okay, and we have values of x1, that is a 2.82328. Okay, so let us verify this value in calculator so we can get ideas how we can solve this type of function. Okay, so we have x, that is a 2.82328. okay, and after multiply is a sine. Okay, x into sin x, x is here 2.82328. okay, bracket over, then after write plus, and cos, the values is 2.82328. okay, this is the form of the function, and replace x1 to this function. The values of x1 we have 2.82328. okay, x into sin x plus cos x. First check the calculus should be in radian mode, and then after type this form. Okay, so it will be minus 0.066178647. okay, so this answer of function. And now let us check the derivative output, and we have derivative is x into cos x. So 2.82328 into cos 2.82328. okay, bracket over, and it will be minus 2.681452. okay, so let us replace this both value in this table, and uh, we'll get answer of second iteration. Okay, so this both value that I have mentioned here minus 0.06618, just verify it with your calculator. Okay, and for any query, any doubt, just ask. So, and then after its derivative output that we have minus 2.68145, and now use this all value in this formula, and we have its formula of x2, that is x1 minus f of x1 upon f dash of x. Okay, so it will be 2.82328, that is x1 minus f of x1, that is minus 0.06618 divided by f dash of x1, that is minus 2.68145. okay, so three negative sign is here exist. Okay, three negative sign, so it remaining will be the negative. So just remove this all the three negative sign here. Okay, and here consider the negative, that is final one. So subtract 2.82328 minus this division. Okay, 0.06618 divided by 2.68145. So that yes, Mohammed replied the answer as Goodison, that is a 2.7986. That is 2.79 85999324. Okay, so you just round off with this value. Okay, the actual form the answer is 2.7985 something. You will get this form in calculator. Okay, and just round off it up to the 4 decimal. So here it is after 5, the digit are here 99324. Okay, it is greater than 5, so we can consider this a fourth digit. Okay, as a 6. So okay, so it will be 2.7986. Otherwise you can consider 2.7986 is also one correct from your answer. Okay, you can start with the next iterations by using a 2.798685 also. Clear? So this is answer of x2, and now for next iterations use n is equal to 2, so it will be the x2 2.7986, and now this is a function output and its derivative output. Let us verify this both value. 2.7986, that is the values of x, and we have function is x into 2.7986 into sine. Okay, 2.7986. Okay, clear? That is x into sine x plus cos. Cos 2.7986. Look it over, and you will get a minus 0.00056 3851. Okay, that is a function output. And now let us check the derivative output. 2.7986 into cos 2.7986. Okay, and the answer will be minus 2.6355888362. Okay, so I have mentioned this both value in this third row. Okay, that is here 2 point minus 2.63559. Okay, and here I consider up to the 5 digit minus 0.00056, and then after replace this all value in the formula will be 2.7986. Okay, third iteration 2.7986 minus again there is a 3 negative signs will be arise in this form. Okay, so remaining will be the negative, and here it is 0.00056 divided by 2.63559. Okay, it will be 2.63559. So just check this form in your calculator, and you will get this type of answer. I think 2.7983 something. Okay, check the answer in your calculator. 2.7986 minus, yes, some reply that that is good. Okay, 2.7983, 2.79838752 form. Yes, very good. We'll get the actual form of the answer. Okay, in your calculator, that is a 2.79 8387524. Okay, and I have considered it here 2.798309 because after 3 the 5 digit are in the form 87524. Okay, there is 8 here, so we can convert this 3. Okay, yes, that is you can consider 8 3 form also. Otherwise you can convert this 7, otherwise 8, either to the 4 8 4 something, otherwise you can consider 839. Okay, 7524 is 4 digit here, so convert this 8 to the 9 form, otherwise 3 to the 4. Okay, this both is correct form there. So I consider here 2.79839. Otherwise, in place of that, you can also consider 2.7984. It is also one correct form your answer. No, that is Hassan. Here is one form, actual form is given that correct up to 4 significant digit. So what is meaning of that correct up to 4 significant digit? We'll consider the 4 digit, okay, after the decimal, and we'll check the 2 consecutive iteration should be matched, should be same, correct up to 4 decimal place, means correct up to 4 significant digit. Okay, here in this first iteration, that is a x1, that is x2. So here match this both answer. Okay, here it is a 2.82328. Okay, the 4 digit after the decimal 82328. Okay, and here the 4 digit after the decimal, that is a 7986. So they are not matched. Okay, after the decimal, the digit are not matched after the decimal. Okay, so we'll repeat this procedure. Okay, and we'll check that the 2 consecutive iteration means either it is x2 x3, otherwise x3 x4, otherwise x4 x5, that should be same. Okay, correct up to 4 value, correct up to 4 decimal places. Okay. So for x2 we'll consider 2.7986 and we'll get answer 2.79839. Otherwise you can consider 2.7984. Okay, that is also one correct form of your answer. And then after again we'll repeat this procedure. Why it is? Because the x2 and x3 answer, x2 answer is here 2.7986 and answer of x3 2.7983. Okay, 8 3 3, the fourth digit here it is a 6, and here fourth digit is 3, so they are not matched. Okay, it is correct up to 3 decimal place only right now. Okay, so we'll again repeat this procedure and we'll match the up to the 4 decimal place. Okay, so for n is equal to 3, we'll get a fourth iterations, that is x3 2.79839, and this is the output of the derivative 2.79839, and let us check to this function is 2.79839, okay, into a sine 2.79839, okay, bracket over plus cos 2.79839, okay, and you will get minus 1.042 into 10 raised to minus 5. Okay, and second one is there 2.79839 into cos 2.79839. Okay, that is the derivative output, and that will be minus 2.635192. Okay, so both output I have mentioned in this fourth row. That is a minus 0.1 minus 1.10 raised to 5 something, so it can be right as a minus 0.00001. Okay, and here it is minus 2.63519. Clear? And that is the x3, so use it in the formula, and it will be a 2.79839 minus 0.00001 divided by 2.63519. Okay, so it will be we'll get 2.79839 something like that. Okay, you will get answer 2.79839. Okay, so now compare this x3 and x4 answer. Okay, two consecutive answer, that is x3 and x4. Okay, so x3 answer we have 2.7983, and x4 answer is also same 2.79839. Okay, so they are matched up to the 4 decimal place. Okay, after the decimal the 4 value are in repeated form. So at that stage we'll stop this procedure. Okay, we'll stop the procedure and we'll consider 2.7983, that is our required answer. Okay, and Hassan reply that correct answer form. Okay, 2.79838 something and so on. So consider up to 4 to 5 decimal after the okay, 4 to 5 value after the decimal, and just match it. Okay, as per the example. Okay, as per the conditions which is mentioned in the questions. Okay, check your answer correct up to 4 significant digit. If it is given that 5 significant digit, will match the 5 digit. Okay, after the decimal. If it is given here 3 significant digit, will correct. Okay, will match a 3 digit after the decimal. Okay, if it is given here 3 significant digit, okay, 3 only, then we'll stop this process up to the third iteration, because in the third iteration x2 and x3 are repeated up to the 3 decimal place. Okay, so this is our final answer, 2.79839. Yes, have you any query now or any doubt? So you can ask me. Yes, any doubt, any query? Okay. So let us discuss this last one.
Sir?
Yes, yes. Yes, Dana.
Sir, is the value is repeat we stop in 3 items?
If it is given here, if it is given here, correct up to 3 significant digit. Okay, in this lesson.
Yeah, it's when x is 3 and 4, the value is same.
Yes. If it is given here, correct up to 3 significant digit. Okay, then we'll check the 3 digit after the decimal. Okay, in these 2 consecutive iterations, we'll match a 2 digit after the decimal. So now in x2 and x3, answer of x2, that is a 2.798, and answer of x3 it is a 2.7983 something. So the 3 digit are repeated, okay, after the decimal in this answer. So at that stage we'll stop the procedure if it is given here uh, uh, conditions given here for 3 significant digits. Okay, so we'll stop this procedure up to the third iteration. Now it is given
Yes.
4 significant digits, so we'll repeat this procedure to the next iterations also. In the x4 answer, okay, in this answer of x4 we get a 2.7983, and answer of x3 we also met 2.7983. So they are now met up to the fourth digit, okay, up to the 4 decimal place. So that depends on the condition which is mentioned in this questions, how many iteration is required. Okay, there is a 2 types of condition. That one is a up to the 5 iteration, means there is a 5 iterations only. Okay, up to the 3 iteration means 3 iterations required only. Up to the 2 iteration means 2 iteration required only. But another one is that correct up to 5 significant digits. So in this case iterations will not fix that. Okay, you can get answer up by only the 5 iterations and so on. Okay, correct up to 5 significant digits. Okay, correct up to 4 significant digits. There is another case to derive the answer. Okay, in this case you have to predict such iterations. Okay, you have to derive such iterations that the 2 consecutive iterations should be same as per your condition, and at that stage we'll stop this procedure and we'll consider that will be our right answer. Okay, that is our required answer.
Yes, sir. Another question, please.
Yes, ask me.
Sir, the x is always equal to b.
X is always
Equal b.
I didn't get this question. Yes, repeat the. Yes, hello. Will you repeat your question, please?
Sir, your voice is not very clear.
Okay, hello. Am I audible? Hello.
Yes, yes.
Yes, please ask.
X is always equal b, or this time, just this time.
No, here it is x is equal to, that is a pi is given. Okay, sometimes this value is not given in this questions. X0 is not given in this question. So for this case we'll predict this value of x0 by using the interval AB. Okay, by using the interval AB. In this second example we had consider this condition. Here in this first one x0 is given. Okay, x0 is equal to 1. So we'll start this value. I will start the iteration by using this value. And in the second example, here x0 is not given. Okay, now read the example number 2. The x0 is not given in this example. So for this case, we'll use this trick. Okay, we'll use these conditions to predict a and b first. Okay, where f of a is a negative, f of b should be positive, and then after we'll consider it average value as a value of x0. Okay, if it is not given, then we'll use this process to get the x0. But if it is given in the question, then you can use this value to predict the x1. Is it clear, Jaina?
Yes, sir. It's clear.
Okay, good.
Sir, what about what about value of n?
N, it is n means there is a suffix value. Okay, it is based on the formula we just predicted. It is here in this first iterations we required x0, then after f of x0, f of x1, and so on. Okay, so therefore we are consider n is equal to 0. Okay, so xn will become x0, f of xn will become f of x0, and f dash of xn will become f dash of x0. Okay, and here in this formula put n is equal to 0. So formula will become x1 is equal to x0 minus f of x0 upon f dash of x0. Okay, so these three value are the values of x0. This value is -1 is f of x0, and minus pi, that is f of x0. Okay, and then replace it in this formula. You can find x1, and now in second iterations these values are known as a x1, f of x1, and f dash of x1. Okay, and in this formula will become, put n is equal to 1 here, so it will be x2. Okay, xn plus 1 become x2, and that is x1 minus f of x1 upon f dash of x1, and so on.
Done, sir.
Okay, and now the next question is there, x is equal to cos x. This question is already we had completed in the bisection method. And in this example, we had predicted 11 iteration. Let us take this question again, and then after we'll discuss this question. In this bisection method, we had already completed this example. Okay, this one. The same data is there, same equation is there. X is equal to cos x minus cos x equal to 0 means x equal to cos x form. By using bisection method, correct up to 2 decimal place. Okay, so for this required answer, we have predicted the 11 iteration. Okay, at 11 iterations we get a similar form answer, means the 2 consecutive iterations are same up to the 2 decimal place. Okay, so here it is required 11 iterations to predict that answer. Okay, so now let us check the same questions by using Newton-Raphson method, and let us check that how many iteration is required to predict that answer. Okay, and based on that we'll identify which method is the most effective method. Okay, which method is a suitable method to predict the fast answer. Okay, same question is here, same function is given that, and here we'll check this answer correct up to 3 significant digit by using the Newton-Raphson method. Okay, and here one word is given, that positive root. So what is meaning of positive root? Okay, if we consider interval AB as a positive value, okay, interval AB as a positive value 2, 3, 5, 2, 0, 1. So in this case, we'll get answer in this positive form. Okay, and if we consider A and B as a negative value, let us take -2, -3. At -2 function get positive and -3 function get negative. So in this case, we'll get answer in negative root form. Okay, so that is simple. So positive root of the equations x is equal to cos x by using a Newton-Raphson method, correct up to 3 significant digits. Okay, so we'll solve the same questions. Okay, same example by using Newton-Raphson method. Okay, and we'll check the answer, the same answer that we already know, 0.73 something, and we'll check that how many iteration is required in Newton-Raphson method. Okay, and then after we'll compare this both method, and we'll find one result. Okay, which method is the most effective method, which method is a suitable method to predict a fast answer. So here fx is equal to x minus cos x. Okay, the fx equal to 0 form, that is x minus cos x, and now its derivative. So derivative of x, that will be the 1. Okay, and derivative of minus cos, that will be the plus sign. Okay, so it is a 1 plus sin x. Derivative of x minus cos x, that is the 1 plus sin x. And now here x0 is not mentioned, so for this x0 we'll consider one interval AB where f of a is a negative and f of b is a positive. Okay, so at 0, answer of f of 0. Okay, so f of 0 will become 0 minus cos 0. Okay, and cos 0 is a -1, so output will be the -1, it is negative. And now at 1, f of 1. Okay, so just check this f of 1 output in your calculator. 1 minus cos 1. Okay, 1 minus cos 1, so it will be 0.4596 something. Okay, 1 minus cos 1, it is a
It's
0.4.
equal 0.000152.
No, that is 0.4596 something. Just check it again. First, consider your Kelsey in radian mode, and then after type this form 1 minus cos 1, and then check it output. 0.459697, you will get the answer of f of 1.
Sir,
Yes, yes, Jena, you got it?
can I share my screen?
Yes. Yes, first check Kelsey should be in radian mode, and then after check your answer. Yes. So how many of you got this answer in calculator? 1 minus cos 1 value. That is 0.459697.
Sir, I can't share my screen, but in calculate, the answer is 0.000152.
Okay, first check. It should be in radian mode. Is Kelsey in radian mode or not? Change the
What is
Kelsey.
degree?
No, it is first consider in radian mode. Okay, then after you will get this answer. And in this numerical analysis, first keep your Kelsey in radian mode and then after solve any example related to this theory. Okay. Okay, so here you will get answer 0.459697. So just round off with this value as a 97. Otherwise, you can consider the 4596 also. Okay, that also one correct form of your answer. Okay, doesn't matter. So 0.4597. That
Sorry,
is yes.
present your screen, please.
Oh, sorry. Yeah, it is visible to all. Okay, good. So here you can consider 4597 as a f of 1 value, and that is positive. So here at 0 we get negative answer -1, at 1 we get positive answer. So we can consider x0 as its average value a plus b by 2, and that will be 0 plus 1 by 2, and 0 plus 1 by 2 will be a point of 5. Okay, so now in first iterations we'll consider x0 value, that is 0.5. Okay, and now check f of x0 value. I just write down it directly. You just verify this value, okay, with your calculator, and for any query, any doubt, you can ask me. Okay, f of x 0, that is 0.5 minus cos 0.5. Okay, and that will be a minus 0.3775. Okay, otherwise 377 only. And then after derivative value, that is 1 plus sine 0.5. And that will be a 1.4794. 1.4794. Okay, this is the derivative value. And now the values of x1, that will be a 0.5 minus of 0.377 divide 1.4794. It is 2 times negative sign. Okay, so it will be convert to the positive 0.5 minus of 0.377. Okay, and here it is denominator 1.4794. So two negative sign it here. Okay, will arise, so it convert to the positive. So just mention here positive in between them and check this output. So 0.5 plus 0.377 divided by 1.4794. So it will be a 0.245. 9. That is the 0.75 something you will get. 7548 833. Is it correct or not? Yes. Yes, Hassan got the right answer, 0.755. Okay, let me check it, my answer.
Yes, sir. It's 0.754.
Yes. Yes, that is the correct one. 0.75 48. Is it correct or not? 0.75. Yes, correct. Okay, good. And now use this value to predict the second iterations up to the 3-digit. You can consider it here. You can consider 0.755, otherwise 754. Okay. So let us take 0.755, okay, and here let us check it output.
Sir, it's minus 0.064.
Okay. Zero 0.755 minus cos 0.755. It will be
It's not minus, not minus.
not minus, that is plus
Yeah, it's
0.0267.
0.0267. Yes.
Yes, good.
Two.
And now a derivative output will be 1 plus sine 0.755. That will be 1.685288. Okay. And now the formula of x2, that will be 0.755 minus. Now both value are positive, so here remaining is the negative only. So 0.02672 divided by 1.6852. So 0.755 minus, and after bracket 0.02672 divide.
0.73914.
Yes, very good. That is 0.739144. Is it correct? 0.739144. Okay. The second iteration 0.73911. Okay. And now the third iterations x2, let us consider 0.739. Okay, 91, otherwise 911 you can consider. And its derivative output, that is 0.739 minus cos 0.739. Okay. And that will be minus 0.000142. Okay, minus 0.000142. That is the derivative output, and it's function output. And now the derivative output will be, it is 1.673549. Okay, and here in the formula of x3, that is 0.739, and that is a minus sign here, so remaining is positive here, and 0.000142 divide 1.673549.
Sir, it's 0.7390.
Okay.
Correct, sir?
Yes, 0.739. That is 0.7398. This form. As how many of you got this answer? 0.73984. Here it is, plus between them 0.739 plus, and then after this division. Yeah, is it correct answer? 0.7398 of the third
Yes,
iteration.
sir.
Okay, good. So now compare the x2 and x3. Okay, compare these two iterations, x2 and x3, and here we required answer correct up to a 3 significant digit. Means in the two successive iterations, two consecutive iterations, the value should be same. Okay, after the decimal, means 3 values should be the match after the decimal. So here it is a 739, and here it is also 739. Okay, so at that stage we'll stop this procedure and we'll consider our required answer, that is 0.739. that is one approximate equation, approximate solutions of the given equation x is equal to cos x. Okay, so now yes.
From where we take xn? xn values of xn, from where we take it?
That is the general form of the xn, and we just put n is equal to 0, 1, 2, 3 and so on to predict this formula. Okay, for n is equal to 0, you will get here x, that is the form of the formula, xn plus 1 is equal to xn minus f of xn upon f dash of xn. Okay, this is a general form of the formula. And now replace n is equal to 0, so you will get a first iteration formula. Okay, the x1 is equal to x0 minus f of x0 upon f dash of x0. Then after put n is equal to 1, we will get a second iteration formula. It is x2 is equal to x1 minus f of x1 upon f dash of x2. Okay, and here we just replace directly this value to this formula. Okay, that is x0, that is f of x0 value, that is f dash of x0 value. Okay, and here we just replace in this formula of x1. Okay, that is a value of x1, that is f dash of x1 value, that is f dash of f of x1 value, that is f dash of x1 value, and the formula of x2 will be x1 minus f of x1 upon f dash of x2. Yeah, so just we replace directly this value here and we can get the answer. That is a general form, the formula only, not a particular values there. Okay, and as per our requirement we can create the formula. Okay, yeah, is it clear, Reena?
Yes, sir. It's clear.
Okay, good. So here you can compare this both method. Okay, in this example, okay, in this bisection method we had derived the 11 iteration. Okay, at 11th iterations we can predict our answer correct up to 2 decimal only. Okay, and now in this Newton-Raphson method we can predict the answer. Okay, correct up to 3 significant digit in just 3 iteration. Okay, within this 3 iteration, in the third iterations we can predict that answer correct up to 3 decimal place. Okay, and in this bisection method we had predict the answer correct up to 2 decimal only. Okay, only 2 decimal, 0.73 only. We predict that answer up to the 11 iteration. Okay, so comparison to this one, okay, this NR method is most effective method, most suitable method to get a very fast answer. Okay, very quick answer. And so comparison to this bisection method, Ruggiero-Falsi method, okay, and NR method, this third method is the most effective method. The rate of the convergence of this method is very high. Okay, to predict the fast and speed answer. Okay, speedily answer of any types of equations you have. The comparison to the bisection and Ruggiero-Falsi, this method is most effective and most suitable method. Okay, to predict the fast and speedy answer. Okay, of any types of equation you can consider. So in bisection method, the 11 iterations required. If you solve this same example, x equal to cos x by a Ruggiero-Falsi method, I think it will take 7 to 8 iterations to predict the same answer. Okay, but in this NR method, in this Newton-Raphson method, we can get the answer up to the 3 decimal place. Okay, up to the 3 decimal, 1 digit you have to add more. Okay, in this case, so up to the 3 decimal, we can predict this answer within this 3 iteration. Okay, so this is the importance of this method. Okay, and you can find a very quick answer. Okay, very speedily answer of any types of equations by using NR method. Okay, so rate of the convergence of NR method is very high comparison to the bisection and Ruggiero-Falsi method. So is it clear to all? Have you any query, any doubt? So ask me. And we'll discuss some more example in the next lecture. Let us take the attendance and then we'll conclude the today's session. I think 2:40 is already done. Just give me the 1 minute.